Across the world, scientists and space enthusiasts alike remain fascinated by the ever-unfolding mysteries of the cosmos among the celestial bodies that continue to spark imagination and inquiry. Proxima B, a planet orbiting the nearest star to our own Sun, has emerged as one of the most intriguing. The fascination with this distant world has grown considerably following the James Webb Space Telescope's release of its most detailed and precise imagery of the planet to date. This monumental advancement has not only provided clearer visual data but also reignited age-old questions about the possibility of extraterrestrial life. What secrets could this small rocky planet harbor? Could conditions there support life in any form? And perhaps most compelling of all, what has the James Webb Space Telescope actually revealed about this faraway world and its unique characteristics? To answer these questions, we must first appreciate the immense complexity involved in observing such distant objects. Understanding how galaxies, stars, and planetary systems form requires peering into the deepest layers of cosmic history, back billions of years to the earliest epochs of the universe. The James Webb Space Telescope represents the most advanced observational tool humanity has ever created for such a task. Unlike previous instruments, it can observe celestial phenomena in the infrared spectrum with extraordinary sensitivity and resolution. This capability allows it to detect the faintest heat signatures from some of the oldest and most distant structures in the universe, offering a kind of time machine that lets us look back to the birth of stars and galaxies, and even to moments shortly after the Big Bang itself. The telescope acts like a sophisticated filter applied to the lens of a camera, isolating very specific wavelengths of light that reveal hidden details invisible to the naked eye or to traditional optical instruments. Armed with this powerful technology, astronomers have been able to expand their understanding of galactic evolution, star formation, and planetary composition. One of the telescope's most significant contributions is in helping researchers investigate the atmospheres of exoplanets, planets that orbit stars beyond our own Sun. By studying the way light passes through these distant atmospheres, scientists can detect the presence of key elements such as oxygen, methane, carbon dioxide, and water vapor, chemical signatures that may hint at the potential for life. Moreover, the telescope has unveiled massive amounts of unseen matter in large galaxies, far surpassing the mass that earlier models predicted, challenging long-standing assumptions about the structure and density of the cosmos. These discoveries have fundamentally altered our models of galaxy formation and the distribution of dark matter in the universe. Yet among all these remarkable revelations, perhaps none is more captivating to the public imagination than Proxima B and Exoplanet orbiting the red dwarf star Proxima Centauri. This planet, residing just over 4 light-years from Earth, is among the closest known exoplanets and one of the most likely candidates for habitability outside our solar system. Proxima B was first identified in 2013, not through direct observation but by noting the subtle gravitational effects it exerted on its parent star. These minute wobbles in the star's position indicated the presence of an orbiting planet, setting off a flurry of interest and further investigation by the global astronomical community. The planet's orbit is extraordinarily close to its star, approximately 7.3 million km, or roughly 20 times closer than Earth is to the Sun. This proximity allows Proxima B to complete an entire orbit in only 11.2 Earth days, creating an unusual and intense dynamic between the planet and its star. Proxima Centauri, a red dwarf, emits only a fraction of the energy our Sun does, but its light is concentrated in the infrared spectrum. To an observer standing on the surface of Proxima B, Proxima Centauri would dominate the sky, appearing as a large, glowing red orb roughly 3 times the size of how the Sun appears from Earth. The eerie perpetual twilight that might bathe the planet's surface due to the red dwarf's dim glow evokes imagery far removed from our familiar blue skies and sunlight days, despite being located in what is called the habitable zone, the region around a star where conditions might support liquid water. Proxima is far from Earth-like. One of its most striking features is the likelihood that it is tidally locked. This means one hemisphere of the planet permanently faces its star, basking in continuous daylight, while the opposite side is shrouded in perpetual darkness. This configuration creates severe environmental contrasts. The day side would be exposed to constant radiation and high temperatures, potentially leading to scorching barren landscapes. Meanwhile, the night side could descend into a deep freeze where temperatures might plunge well below freezing. The narrow region between these two extremes, the so-called terminator zone, might in theory offer more stable and temperate conditions, yet even this slim region is threatened by other cosmic forces that make habitability uncertain. Another major obstacle to life on Proxima B is the behavior of its host star. Red dwarfs, although smaller and cooler than our Sun, are known for their volatility. Proxima Centauri in particular is characterized by unpredictable and powerful solar flares, intense magnetic activity, and radiation bursts. These stellar outbursts can bathe nearby planets in dangerous levels of ultraviolet and X-ray radiation. In April 2021, for instance, Proxima Centauri unleashed one of the most energetic flares ever recorded from a red dwarf. This event was nearly 100 times more intense than any previously observed, briefly outshining the star's baseline brightness and bombarding any nearby planets, including Proxima B, with levels of radiation that would be devastating to unshielded life as we know it. Factors raise serious concerns about the long-term stability of any atmosphere the planet might possess without a strong magnetic field or thick atmosphere to offer protection. Any potential biosphere would face incredible challenges to survival. Yet, despite these extreme and unwelcoming conditions, Proxima B continues to captivate researchers and the public alike. The possibility of life beyond Earth, no matter how remote, remains one of humanity's most enduring obsessions. In late 2020, this fascination deepened when astronomers detected an unusual narrow-band radio signal from the Alpha Centauri system. The signal, measured at 982 MHz, did not match any known type of satellite interference or naturally occurring radio emission, though the signal was never confirmed as extraterrestrial in origin. Its anomalous nature sparked intense speculation. Could this be a sign of intelligent life? Was it evidence of a technological civilization transmitting from a nearby star system? While the signal's origin remains unverified, it underscores how difficult it is to obtain definitive answers about distant planets and star systems. Reaching Proxima Centauri with current propulsion technology would take tens of thousands of years. However, new initiatives are being explored that could revolutionize interstellar travel. One of the most ambitious is the Breakthrough Starshot project, which envisions sending lightweight wafer-sized probes to Alpha Centauri using